Hey, we're back with our free ABB ACS 880 drive. We've already cleaned it up and we static checked it, and now we're about to reform the capacitors. If you're not familiar with reforming the capacitors, I'm just going to quickly walk through why we do it here at Last Tech Automation and kind of what our process is. Electrolytic capacitors are in the center of any VFD. And these capacitors actually have a shelf life. You can't let them sit for too long without having voltage applied to them. Whenever we apply voltage, there's actually a reaction that happens inside that rebuilds the oxide layers, and the oxide layers are essential to preventing internal arcing, which can lead to pressure buildup and capacitor explosion. And so what we end up doing is we use a variac to slowly raise the voltage over the course of generally about 8 hours. So the drive that we have here was given to us by one of our customers whenever they switched to fully 460 volt AC drives on their whole plant. This one happens to be a 230 volt drive, and so we're going to base everything off of that voltage level. So what we got is a cheap Amazon variac. This variac was less than $60, I believe, and it's going to be supplied with an extension cord, just normal 110, 120 volts, and then we've got an outlet for the output on here, which is going to vary the voltage output as we turn this dial. We have the load plugged into it, which is hardwired step up transformer. So this is actually a 460 to 230 volt transformer on the primary, and the secondary is 110 volts. With this transformer, we have it wired up backwards so that if we give it voltage on its secondary on the 110 volt side, we will get out of the primary either 460 or 230, depending on how we have it wired. Like I said, this is a 230 volt drive, so we are actually going to wire this with the coils in parallel, and that will give us 230 volts when we give 115 in. So it'll essentially just double our voltage. If we have the primaries coils hooked up in series, then it will quadruple whatever we put into it. And that's how we can get up to 460 volts with just a very small, cheap Amazon variac. So what we're going to do is, for a 230 volt drive, we are going to take it up solid increments, and we're going to let them sit there for an hour. For 230 volts, it's going to be 25 volts an hour, and we're going to let it sit. We're going to come back. We're going to raise it up another 25 volts, let it sit for another hour. On a 460 volt drive, our standard is to do 50 volts an hour. Same process, put it on 50 volts AC on the input on the line 1 and 2 on this particular drive. And we are going to let it sit there at 50 volts for an hour, raise it up to 100 volts, let it sit there for an hour, all the way up until we get to 460 or 230, whatever your rated voltage is. That needs to sit there for an hour, and then you can switch over to your normal three-phase, your line voltage, and just throw the power to it. We're going to talk about a few of the things that we're going to look for and we're going to listen for as we do this process, that would indicate to us that there could be an issue. So whenever I have the drive powering up, I'm going to take my fluke here and I'm going to clip it onto the DC bus terminals. I'm going to be watching and listening for some things. The thing that I'm going to look for is I'm going to look for a rise of the voltage. If the voltage ever sags and starts dropping down, that indicates to me that there is an internal arc and that it's not going to work. This is going to fail, and we ought to just go ahead and stop right there. Whenever it is dipping like that, a lot of the times I will hear a little crack, just a tiny little tick. Sometimes it's a little bit louder, sometimes it's a little bit quieter, but a tick normally indicates that there's internal arcing of the capacitors. So we're going to go ahead and abort the mission right there. Some of these drives can have new capacitors installed in them, but this is throwaway culture nowadays. So typically really under like 150 horsepower is considered throwaway for most brands. The bigger 500, 1,000 horsepower, the giant HHP modules, those are going to be rebuildable. But things of this size, you're very hard pressed to be allowed to buy parts for them. So typically at that point, you're just looking for a new drive. If it's not fans or the control board, you're probably just going to have to get a new drive. So we're going to switch over, and here in just a moment, we're going to start powering up this drive. But before we do that, I just wanted to show just a quick example of what this does whenever we have it powered up. So without the drive connected to it, I've got my meter leads from this one showing the output of the Variac, and this one shows its doubled voltage coming out of the transformer. So if we turn this guy on, it's all the way at 0. We have 0 volts. Let's go ahead and come up somewhere around 10 volts. Let's see, about 10 right there, and we show about 20 volts there. So if we come up to 50, whatever we put into the transformer, we should right about double it. So we got 50 volts there, we got 100 volts on the output. And then as we crank it all the way up, you see I give it 115 in, and I get 230 volts on the output. So that's how we can take normal extension cord power, just 110, and boost it up for this application. This is a very low current application, and so we are not really required to have huge availability of power for this, because we're just slowly raising the voltage and letting it sit there. It's not going to be draining a lot. We're slowly charging the capacitors, and so we are not going to be able to run a motor with this setup, but we are going to be able to reform the capacitors. And once they get to that full level, we can switch over to normal 3-phase power, and we can then start testing our motor here. All right, our drive has completed powering up. We're at 230 volts AC. You see there's our AC voltage. Our DC bus is now up to 307. We didn't have any issues that were detrimental to this project. The capacitors sounded good. We didn't have any arcing or popping, no surging coming from the transformer or the Variac. And we did encounter one issue that we wanted to talk about. We ended up taking out the DC cooling fan. This is a 24-volt powered unit, and when the DC bus reached about 90 volts, the 24-volt DC power supply, which powers up the control board and the keypad and the cooling fans, that would kick on, and there was a fairly significant voltage drop, I believe, happening because of the pre-charge resistor that's in the circuit. This is still in the circuit until the bus gets to a certain level and the SCRs are gated on fully, bypassing that resistor. So for now, it was on, and we were seeing a fairly significant drop. So for that third 25-volt increment, we actually did 35 volts to kind of get over that hump. Once it powered all the way up, we were able to get full voltage and everything came online. And now we can use the keypad to make a backup copy of the parameters. This thing can show us all of our faults. We can get it set up and we can continue on with our testing. So we're about to take this off of our Variac, our small test setup, and we're going to hook it up to the main line, and we're going to start running this motor here pretty soon.